Every day, more than 110,000 tons of glass are produced around the world. In the United States alone, millions of tons are consumed every year. Meeting this enormous demand requires processing millions of tons of sand. But how does this fine powder become one of the most widely used materials on Earth? Today, we're going behind the scenes to discover how glass is made by melting silica sand. Modern civilization simply couldn't function without it. This engineering marvel is everywhere. It's an essential part of buildings, automobiles, and smartphones. Although it appears fragile, glass can be incredibly strong. When reinforced, it can withstand extreme temperatures, intense pressure, and even powerful impacts. Thanks to its remarkable durability, glass has become one of the most important materials in modern construction. But it wasn't until around 3000 BC that glass was first discovered by accident by the ancient Egyptians. While heating silica sand together with soda ash near a fire, they unintentionally created a glass-like substance. At first, glass was mainly used for decorative purposes, such as jewelry and small amulets. By the late 19th century, however, glassmakers had achieved something extraordinary: luminous, translucent glass. Back then, manufacturing glass was slow, expensive, and difficult. Large furnaces melted the material before it was poured onto flat surfaces. The process was inefficient and often produced sheets filled with imperfections. Everything changed in 1959 when Alistair Pilkington invented the float glass process. This revolutionary method continuously produces flat glass by floating molten glass across a bath of liquid tin. Thanks to this innovation, manufacturers could finally produce perfectly smooth, crystal-clear glass on a massive scale at a much lower cost. But where does silica sand come from? Although it's one of the most abundant resources on Earth, not every type of sand contains the purity needed for glass production. In places such as the massive mines of Brazil, silica deposits are locked inside veins of hard rock hundreds of feet underground. The only way to reach them is with carefully controlled blasting. The mining crew drills holes nearly 36 feet deep before placing explosive charges inside the rock. Their primary explosive is ammonium nitrate mixed with fuel oil, a powerful combination that's both effective and relatively easy to handle. To ensure every charge detonates properly, each one weighing about 130 pounds is primed with approximately 6 pounds of a much more powerful explosive. Once everything is ready, the chief blasting engineer gives the order to fire. After the explosion, huge sections of silica-bearing rock break free. As soon as the dust settles, excavator operators move in. Massive excavators and haul trucks begin collecting the blasted rock, and within a short time, thousands of tons can be removed from the mine. The raw material is then transported to a processing plant, where the silica sand will be refined for industrial use. This is where the purification process begins. The crushed material still contains impurities such as clay and organic matter that must be removed. To clean it, the sand is transferred into enormous washing tanks, where it's mixed with hot water to separate unwanted particles from the valuable silica. After the initial wash, the sand moves on to the drying stage. Inside giant industrial dryers, it's exposed to high temperatures that remove any remaining moisture, along with the last traces of impurities. Once completely dry, the silica sand is packed into 2,200-pound bulk bags and shipped to the glass factory. This is the largest glass manufacturing facility in the United States, and every week it receives more than 5,500 tons of silica sand. Towering silos store the essential ingredients needed to make glass. Every day, more than 770 tons of raw materials enter the production process. Along with the silica sand, workers add soda ash and limestone. These ingredients change the structure of the silica, lowering its melting point so it can liquefy much more easily. Limestone is added to improve the strength and durability of the finished glass. Then comes one of the most important ingredients of all: recycled glass from previous production batches. Adding cullet dramatically speeds up the melting process while reducing the amount of energy required. Pigments are responsible for giving the glass its color. In this case, cobalt oxide creates the rich blue shade commonly seen in certain types of decorative and architectural glass. Once every ingredient has been measured, they're poured into a large double-chamber mixer. Inside, the materials flow from one end of the machine to the other, ensuring everything is blended evenly into a perfectly uniform mixture. When the batch is fully mixed, it's transferred into a massive natural gas-fired furnace, where temperatures climb to an astonishing 3,000 degrees Fahrenheit, about 1,650 degrees Celsius, far hotter than molten lava. At this stage, the furnace operator takes control. The mixture is carefully loaded into one of the furnace crucibles. Once everything is in place, the opening is sealed to maintain precise control over both the temperature and the melting process. Inside the plant, workers must wear fire-resistant suits along with heavy-duty Kevlar gloves. The heat is intense and the work is physically demanding. As the mixture cooks under these extreme temperatures, every movement must be performed with care and precision. To guarantee the highest quality glass, workers use long metal rakes to stir the molten material. Their goal is to remove the air bubbles that naturally form during melting. Although these bubbles may seem insignificant, they can ruin the finished product by reducing both its clarity and its strength. 24 hours later, the material no longer resembles sand. Instead, it flows like glowing lava. At the bottom of the furnace, what shines so brightly is now liquid glass, a thick, glowing mass that has reached the perfect temperature and consistency. Over the next several hours, the glass remains molten, allowing any remaining trapped gases to escape, so the material becomes as pure as possible. The furnace contains 12 separate crucibles, each capable of holding a different color of molten glass. Every crucible can contain up to about 600 pounds of liquid glass, allowing manufacturers to produce a wide variety of colors and products simultaneously. Once the glass is ready, the team has to move quickly. Workers carefully gather the glowing molten glass from the crucibles. With only a few seconds to work, they must carry it swiftly to the mixing table before it begins to cool. The glass is kept in constant motion to prevent it from cooling unevenly, which could affect its quality. The process is so fast and precise that even a slight delay can create defects, cold spots, or other imperfections in the finished glass. The metal ladles must be cooled between every use, otherwise the next batch of molten glass would stick to the surface. These ladles come in different sizes and can hold anywhere from about 4 to 40 pounds of molten glass. To create a single color, workers sometimes pour material from as many as 5 different ladles at the same time. This is where the real artistry begins. At the mixing table, the magic happens. The operator lifts a glowing mass of molten glass and skillfully blends it using a steel fork. It takes years of experience and a trained eye to master this process. Mixing too much produces dull, muddy colors. The secret is knowing exactly when to stop, creating the perfect balance of shades without overworking the material. Next, the molten glass is placed into a rolling machine, where it passes between heavy rollers that flatten it into a smooth, even sheet. These specialized rollers apply just the right amount of pressure, stretching the glass into a thin, uniform panel with a consistent thickness from edge to edge. The operator carefully separates it from the work surface while removing any trapped air bubbles that may have formed during the rolling process. The result is a flawless sheet of glass. The newly formed sheet is then transferred into an annealing oven, where it cools gradually under carefully controlled conditions. This slow cooling process relieves internal stresses that develop while the glass is still hot. Without annealing, the glass could crack or shatter unexpectedly as it cools. Once the glass has fully hardened, it's ready for cutting. After cooling, each sheet moves into the cutting area, where it's trimmed to its required dimensions. Workers wearing protective clothing and thick gloves carefully handle the panels, whose edges remain razor sharp and are still warm to the touch. Each crucible produces approximately 25 glass sheets every 24 hours, giving each furnace a daily output of roughly 300 finished sheets. Cutting the glass is a delicate operation that requires perfect coordination between two workers. Using an ultra-durable cutter tipped with tungsten carbide, they score the surface with remarkable precision. Once the score line is complete, they apply controlled pressure to separate the glass cleanly along the marked line. The standard panels measure about 32 by 32 inches, providing a consistent size that's ready for shipping or further processing into countless different products. None of the leftover material goes to waste. Every offcut and scrap piece is collected and returned to the melting process, where it will become part of a future batch. Recycling glass not only reduces waste, but also lowers the energy required to melt the raw materials, making the manufacturing process faster and more efficient. Finally, the finished glass sheets are carefully packed into sturdy wooden crates designed to protect them during transportation. Each crate is secured and prepared for shipment to customers around the world. where the glass will eventually become part of homes, office buildings, vehicles, appliances, and countless other products we rely on every day. It's remarkable to think that something as ordinary as sand can be transformed into one of the most versatile materials ever created. Through mining, purification, extreme heat, precise craftsmanship, and carefully controlled cooling, millions of tiny grains become crystal clear glass that helps shape the modern world. Whether it's protecting the screen of your smartphone, letting sunlight into a skyscraper, or providing the windshield on your car, every piece of glass begins the same way, with silica sand and an extraordinary manufacturing process refined over thousands of years. If you enjoyed this video, don't forget to leave a like and share it with someone who might find it interesting. And if you'd like to keep discovering how everyday products are made, be sure to subscribe to the channel and turn on notifications so you never miss a new episode. Thanks for watching, and we'll see you in the next one.